And it goes a little something like
Hello, and how are you? I hope you are staying safe during this daunting season. Today, we are going to cover on an interesting topic, which is application of differentiation, specifically rates of change. We're going to relate some real-life applications to make everything sounds more simple. So, without further ado, let's jump into it. Before we get into the video, I would like to recognize my team members who successfully have produced this video on application of differentiation. So firstly, we have Nur Afina binti Abdul Razak. Next, we have Nurmaya Shafira binti Rabai. And lastly, but not least, it's me, Muna Nazia binti Mama Asman. So let's get right back to where we dropped off, shall we?
What is differentiation? So, in calculus, derivative is the measure of how a function changes its value as the input changes. In other words, you can understand differentiation is a method of finding the derivative for a function at any given point. What is related rates of a change? So, related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rate of change are known. Okay, so now we're going to talk about real-life applications of differentiation. So as you can see in the slide, some real-life applications of differentiation is making a coffee. We can calculate the rate of change of coffee dripping from the columnar filter into the pot. Next is used in chemistry. We are able to measure the rate of chemical reactions and also check the contribution and loss of a compound during a reaction. As you can see in that slide, you can see that a metal foil is burning inside there. So by using differentiation and specifically rate of rates, we can check the contribution and loss of compound during the reaction. So that concludes the examples for real-life applications of differentiation.
So the problem that we want to solve is Nico's bubble blowing machine blows up spherical bubbles whose volume increases at the rate of 8 cm³ per second. So what is the rate of increase of the radius of a bubble when its radius is 10 cm? So the hint are given here, that is volume of sphere is equal to 4/3 pi r³.
Why we choose the problem? We were curious at how the application of the concept differentiation can be observed on trivial things such as bubbles.
And to the suggested solution. So first, we have to derive the needed elements to start solving the question. Let's read through the question again. Nico's bubble blowing machine blows spherical bubbles whose volume increases at the rate of 8 cm³ per second. How can we translate this statement into an equation? So we can write it as dV over dt equals to 8 cm³ per second. Why is our value in the positive? Because it's stated that the volume increases. But what if the question stated that the volume decreases? Of course, our value must be in negative. Next, it asked, what is the rate of increase of the radius of a bubble? So, just write it down here. dr over dt equals to what? This is the main thing that we are going to try and find out from this question. Next, it says when its radius is 10 centimeter. Let's keep this in mind as well. Second step, after retrieving all the needed elements to create an equation, so it would turn out like this. How? I'll show you a simple way. So let's first write this down. dr over dt equals to dr, put this on the top, and then we have dt at the bottom, so let's copy that, dt. So do this first, and then secondly, copy so for this blank spaces here, we can write what is given in the question, the element that is given in the question. So the element that is given in the question is volume. So we can write it there. Now you have your equation. After we obtain the equation just now, this is when it comes into play. So we already have this provided by the question, which is 8 centimeter cubic per second. But then what about dr over dv? This is how you do it. Firstly, it was given that the volume of a sphere is V equals to 4 over 3 pi r cubed. We have to differentiate that. And you would get 4 pi r squared. But remember, this is dv dr. But we need dr dv. So we can reorder it. And when we reorder it, we'll get 1 over 4 pi r squared. On to the next step. We can now substitute the values into the equation because we have obtained dr over dv and we do have our dv over dt as well. So let's do it one by one. What was our dr over dv? 1 over 4 pi r squared, correct? And what is our dv over dt? 8 centimeter cubic per second. So let's write it down. 1 over 4 pi r squared times with 8 will get 8 over 4 pi r squared. And we must simplify it and we will get 2 over pi r squared. If you think that we are finished, no, you are wrong. Why? It's because the question asked what is the rate of increase of the radius of a bubble when its radius is 10 centimeter. So of course we have to substitute r equals to 10 into dr over dt. And it would look like 2 over pi 10 square, which is 2 over 100 pi, which is again simplified. You'll get 1 over 50 pi. And again, you must not forget to put the units in, which is centimeter per second. Why centimeter per second instead of centimeter cubic? Because it requires us to find radius of a bubble, rate of increase of the radius of a bubble, not volume. So it must be in centimeter. So if you are doing the question while following this slide and you get the same answer, you are correct.
So the summary for this is that hence the rate of increase of a radius bubble is 1 over 50 pi centimeter per second.
Okay, so we can conclude that application of differentiation is very important as it helps us to solve various types of real-life problems. as it is used in many scientific fields which are still noticed nowadays. Hence, the application of differentiation was developed as a method to understand and improve the world better.
So these are the links to the websites that we used as a reference in creating this video. So if you're interested, you can check out the links for more information. So before we wrap up this video, I would like to give some acknowledgement to those who had helped throughout the process of creating this video. And firstly, I would like to give some credits to none other than our calculus lecturer, which is Madam Liu Chin-Ying. She had gone extra far length to make sure that we clearly understood the instructions given, and she also checked up on us to make sure that the whole process is running out smoothly and that the whole team members are cooperating while creating this video. And last but not least, I would also like to thank my team members who had tirelessly contribute their efforts into creating this video and were also active in throughout the whole discussions needed to create this video. So, thank you very much.
Thank you for your time.
Okay, here I just want to say thank you for watching, and hopefully you guys can understand all of our explanation in this video.